So lecture 2, forces in equilibrium, vertical and horizontal component of forces. Let's just work upon the force acting towards, this is your normal force acting towards the diagonal side towards right. That means it's acting towards the east and the north. So this becomes your force, and here it becomes the angle. So when you have the force, what we need to understand here is that whenever the force is there, we will always make sure that the force x horizontal and the force x vertical. This creates what? 90-degree angle. This creates 90-degree angle. So if the force is going towards the diagonal east and north, so that means horizontal force will act on the right and the vertical force will act upwards. So what we will end up getting the answer as, since we know the hypotenuse and we know the angle, so the hypotenuse and angle, this should be what? FV is equal to F sine theta. And this should be F cos theta. And how do we get this? You need to understand that considering the same concept, if we just say sine theta is equal to opposite upon hypotenuse, right? So we know one thing, that sine theta is there. You do not know the opposite side, but now you know the hypotenuse is F. Let's say force vertical. So can we just say that opposite is equal to what? Opposite directly will be F sine theta. If we just find out the force, this should be force multiplying with what? Sine theta. So opposite is what? Force vertical, which is force sine theta. Similarly, if we just work upon the cos theta is adjacent upon hypotenuse. So cos theta, whereas it should be force horizontal upon your F. So force horizontal is equal to F cos theta. So what do we have here? We have the force vertical, which is F sine theta, and we have force horizontal, which is F cos theta. But you need to understand that this, when your force is going this way, then your horizontal force will be acting on the right and your vertical force will act towards up. So this becomes the first force, which is east and the north. On the second thing, what we can work upon is, let's say, the force x towards west and north. And you have the theta as well. So what does this mean? This clearly identifies that the horizontal force and the vertical force, this creates 90-degree. Since this becomes your F force and the theta is there as well, so directly what we can write down this thing as, this becomes force vertical, which is F sine theta, and this becomes force horizontal, which is F cos theta. This creates 90-degree and the direction goes on the left and the direction goes towards right. Then we can end up having the force going downwards. That means east south. So at this point, what we need to understand is that force will act horizontally and the force will act vertically. This will create what? 90 degree. What was given was force and the theta. So what we have here is, this should be your force vertical, F sine theta, and this should be F cos theta, which is force horizontal. And lastly, what we can say is, the same concept also applies on the direction where this goes like this. So again, force horizontal and force vertical creates 90 degree. This becomes your theta and this is your force. So this point, this is force horizontal. This becomes F cos theta and this becomes vertical. That means F sine theta. So every time what we can just directly write down is that for force vertical, sine theta is used because of what? Because of opposite and hypotenuse. So F sine theta is there, whereas cos theta is used for F horizontal upon F. So this should be F horizontal is equal to F cos theta. So this is normal force, vertical and horizontal component. Now let's just work upon the resolution of forces. Now, what are resolution of forces? Let's just say that we have been given an x-axis and the y-axis. This is right, this is upwards, and let's say this covers your horizontal force, this covers your vertical force, and there is a line which involves FR, right? So what we gonna do is that if we have the FR and we have what? The opposite and the adjacent. So what we can do is, if to calculate your theta, this becomes your FV and the FH now, right? So let's just work upon that. If I want to calculate FR, so since it is creating your 90 degree angle and we know the force towards the FH, so what we're gonna do is FR is equal to under root FV square plus FH square, force horizontal, force vertical. And similarly, for angle, what we can do is tan theta opposite upon adjacent, which means theta is equal to tan inverse FV upon FH. FV upon FH. Now, what we need to understand is that this angle comes through what? This x anti-clockwise. So whatever theta that we'll get is, we will get anti-clockwise. Whatever theta that we get is, we'll get anti-clockwise, clockwise from x-axis, and that too x-axis is positive. Now this is your resolution force if particularly the transition takes place from the east and the north side. Now let's just work upon this is your horizontal, this becomes your vertical, FH, FV, and there involves a force that is there towards right hand side. So this becomes FR. Let's say this is your theta. So what you will involve is you'll make your right angle triangle, right? When your right angle triangle is there, this becomes FV and automatically this is your FH. Now, FV is a force acting towards what? Downwards, whereas FH is force acting towards left. So what is the basic difference? The FR is going to be calculated the same way. That is FR is equal to what? Under root FV whole square plus FH whole square. And the theta will be calculated same way, tan inverse, which is FV upon FH. But for theta, what we can do is it will, whatever theta we get, it acts clockwise from positive x-axis. It's x clockwise from positive x-axis. So in this particular way, what we need to understand is there can be three different type of forces as well. Let's just work upon them. Let's say that since we already calculated what? We calculated on the top, we calculated what? Towards down. If we calculated up and north, so same thing will be applied when the force FR will be there. This becomes your what? FV, this becomes FH, same theta. But at this case, remember that it is what? Acting, and it is acting what? It is acting clockwise from negative x-axis. This is acting clockwise from negative x-axis. So clockwise from negative x-axis. This is the only difference, whereas the formula will still remain same. Similarly, on the other hand, if the same thing is applied towards the right, towards the south and the west. So this is FR, we can say this is FV, FH, the angle is there. For FR, remember that under root FV square plus FH square is there. For theta, we can always use tan inverse upon FV upon FH. But here what we can see is that the force is acting anti-clockwise from negative x-axis. So this involves this particular concept. Okay, Ji. So now let's just learn how to evaluate the vertical and the horizontal force, which you have already covered in the trigonometric topic of calculating the sine and the cos trigonometric ratios. But let's just work upon it here. Let's say that we have a force that is acting towards east north, which is F 100 Newton. And the angle that we have is, the angle that we have is 40, right? So as we said that since I need to calculate the FV and FH, so let's say FV and FH, right? So to calculate FV and FH, you can just introduce the horizontal force and we can introduce the vertical force. That creates a 90 degree. Your FV will become what? 40 sine theta, sine 100. And this will become FH will be 40 cos. Oh, just my bad. Let's just correct it. This will be FV will be 100 sine 40 and this should be 100 cos 40 because the angle is 40 and obviously the hypotenuse that given is what? 100. So what we can have is that FV can be 100 sine 40, which will be 64.3 Newton. And we can say that this acts up vertically upwards, whereas FH will be 100 cos 40, and this should be what? 76.6 Newton. And this acts what? Horizontally towards right. So these are the what? Vertical and the horizontal force evaluation using the theta and the force which is in the hypotenuse. Let's just work upon the another example. Let's say going towards right, let's have the angle as well. Let's say this is 60 degree and the force that we have is 200 Newton now. So the same question, force V, force H. Let's just write down calculation of force V and force H here, right? So that we know that it's the same thing in each and every example question that we do. So this becomes your horizontal force, this becomes your vertical force, horizontally on the right, vertically downwards. This will be FV, which will be 200 sine 60. And this should be FH, will be 200 cos 60. So if we just write down this thing, your FV will be 200 sine 60, which is 200 sine 60 is 173.2 Newton, which acts vertically downwards. Whereas FH will be 200 cos 60. This acts what? F100, 200 cos 60 will be what? 100 Newton. This acts horizontally towards the left. Another example of such case, let's just work upon the force. Let's say this is FR, 50 Newton, 30. So again, this is 90 degree. This will be FH, which is 50 cos 30. This is FV, which is 50 sine 30. So now what we know is this X towards left, this X vertically upwards. So what we can have here is FV is equal to 50 sine 30, right? So FV is equal to 50 sine 30, which will be 25 Newton. And we can say vertically upwards. FH is 50 cos 30 and 50 cos 30 will be 43.3 Newton, which will act horizontally towards left. If the force is going towards south and west, if the force is going towards south and west with the angle of 50 and the force applied is 150 Newton. So if you want to calculate the horizontal force and the vertical force, this is horizontally towards left, so this should be 150 cos 50. So this is FH. And your FV will be 150 sine 50. So let's just work upon the same concept applied. So 150 FV is 150 sine 50, which is 114.9 Newton, vertically downwards. And FH will be 150 cos 50, which is what, 96.4 Newton. This acts horizontally on the left. So these were the four different example of solving the forces, four different example of solving the forces using the horizontal, using what force and the theta given to it. Now let's work upon the resolution of the forces. Now, what does this mean? Let's say the question is such that there is a force which is given FV, or let's say directly it is given as 350 Newton. And there's a force that is acting horizontally, which is 200 Newton, right? So there will be question that will be asked to find out the angle and the force resultant, right? So there are two questions that can be asked here. One is the angle, the other one is the force resultant. So what we need to understand is that such cases, one thing that we know is that there is a vertical force that is 350. There's a horizontal force that is acting towards horizontal. So that means if the force is being applied from up and on the right, so somewhere the object will move towards the diagonal right hand side. When the force is carried forward up and the force is carried towards right. You can take the experiment as well by telling somebody to hold it from right and to hold it from the front of you. And if they just pull you towards them each other, so you will act diagonally towards the right and the north on this direction. So particularly whenever there is a north and the particularly when there is north and the when there is north and the east pull, you will act towards this side, right? So when you're acting towards this side, so you will involve two things, two major things. One is the angle and the other one is the force resultant. For this, what you need to understand is that this will be your what vertical force. Now you already know that your vertical FV is 350, because if this is 350, then obviously this side will also be 350, the same force. And this is already 200 acting towards right. So moving that particular point, what we can understand is that the force V is 350 and force H is what 200 Newton, right? And since I need to take out the angle, let's say that force H is what 200 Newton. Force H is 200 Newton. Force V is what 350 Newton. If I need to calculate FR, that is force resultant, your force resultant will be under root FH whole square plus FV whole square, right? So this should be force resultant is under root 350 whole square plus 200 whole square. So your force resultant should be what? 403.1 Newton. Similarly, if I want to calculate the theta, there should be 10 inverse and 10 inverse FV upon FH. So vertically, we already know that the angle was FV, which was 350, and your horizontal was what? 200. So theta that is involved here is what? 60.3 Newton. Since it was 60.3 Newton, we know that this is 60.3 and the force is what? 403.1. These are the two answers, but with the angle, we can say it is what? Acting anti-clockwise rotation from positive x-axis. This is anti-clockwise rotation from positive x-axis. So this is particularly the way moving forward for resolution of forces.